right, we're doing the second part of this lesson. We're going to go ahead and do combinations today. So combination is a selection of objects in which the order is not important. So yesterday with permutation, order did matter. And I'm going to show you the difference, visualizing it using the actual orders to tell you and show you what it does. What does it mean when it says order is important, order is not important. So for this one, for combination, we said order is not important. Okay, order does not matter. So this is like when drawing from identical prizes, order does not matter. So giving you an example of what order does not matter is, let's say I have specific colors. Let's say some of my colors were, I want to choose, or let's just say I want to choose two colors, red and yellow. Those are my two colors. What does it mean by order is not important? I'm going to first give you an example of permutation. Permutation, order does matter. So red, yellow is one order. Another order is going to be yellow, red. Okay, this is specifically permutation. If I were to look at combination and I want to say, okay, using the colors red and yellow, combination, what would my combination be? It would only be one of these. Okay, combination says that these are both the same. Red and yellow is the same as yellow and red. So with combination, it would only be one. So whether I want to cross out the top one or the bottom one, combination is saying, okay, again, order doesn't matter. Red and yellow is the same thing as yellow and red. So whatever way you want to write it, it's the same thing. I'm going to have one pair. Whether you want to write it as red and yellow or yellow and red, it's just one. Permutation again states that red and yellow is different than yellow and red. So I would then have two. And you're going to see it in other examples, at least in the next one when I'm going to draw it all out. So, example number 5, again, this is a continuation from yesterday, says, count the combinations of two letters from the list ABC. So this one does tell me that it is a combination. Okay, it specifically says combination, but just as a refresher, I'm going to solve it as a permutation first. So, like I said, I'm going to solve it as a permutation just so we can get that practice. And looking at it, formula for permutation, writing it down because we have to remember that. I'm going to have NPR. This is my permutation. Let me get a little better color, that way you guys can see it. All right, NPR, where I have n factorial over n minus r factorial. That was my formula. So looking at it, what do I have in total? How many letters do I have in total? My n is going to be my 4, and I'm only using 2. So again, this one I'm doing permutation, and then we'll go ahead and do combination after. But solving for permutation, this is what we did yesterday. I'm going to have 4p2, and I'm going to write it as 4 factorial over 4 minus 2 factorial. Solving it, I'm going to have 4 factorial over 2 factorial. Writing it out, I'm going to have 4 times 3 times 2 factorial over 2 factorial. My 2's are going to cancel out. And all I have to do is multiply 4 times 3, which is going to give me 12. So this is what we did yesterday. This is permutation. So I'm going to actually draw out the pattern so you guys can see what that pattern is. So looking at it, I'm going to have A, B, C, and D, and I'm going to write all 12. I'm going to have AB, AC, AD, BA, BC, BD, CA, CB, CD, and this is DA, DB, and DC. So this is all my patterns for my permutation. I have 12 of them. Now, the difference between combination and permutation, pay attention, is if I have AB, combination says BA is the same thing, so I'm going to go ahead and cross that out. If I have AC, CA is the same thing, so I'm going to cross it out. If I have AD, that's the same thing as DA, so I'm going to cross it out. Looking at the next row or column, I have CB, it's the same thing as, or BC is the same thing as CB. I have BD, that's the same thing over here. And then this is the same thing over here. So for my combination, I'm going to have 6. Okay, how am I solving that? Now I'm going to go ahead and I'm going to solve for combination. Pay attention to the formulas because they're going to look very, very similar, but there's one difference. So writing out my formula for combination, like we have it on the calculators. You guys have seen it on the calculators. I'm using that C. It's going to be NCR. But my formula is going to look a little different. So far, it all looks the same. I'm going to have n factorial over n minus r factorial. Again, looks very, very similar. Nothing's different so far. The only thing that's changing is now I'm going to do times r factorial. That's the difference. I'm multiplying that extra r factorial. So plugging it in. What is it going to look like if I actually plugged it in and I actually solved it? I'm still going to be using the same n and r. I'm still using the same thing. It's just a matter of how I'm solving it. So plugging it into what I have. I'm going to have 4C2, which is 4 factorial over, writing it out here, over, I'm going to do 4 minus 2 factorial times 2 factorial. All right, looking at it now, solving this, I'm going to have 4 factorial over 2 factorial times 2 factorial. Please, most important thing for this, do not multiply these, okay? Do not multiply. Please do not multiply those. Do not forget that. Do not multiply them. How is it going to look like if I'm writing it out? I'm going to go ahead and I'm going to take it and I'm going to go 4, 3, 2, 1. Then I'm going to have 4, not 4, just kidding. I'm going to have 2 times 1 and 2 times 1. These two 1s are going to cancel out. Okay, they're going to cancel out. I'm going to get 1 and 1. Now looking at it, can I simplify anything here? Yes, I can. I can simplify 2 and a 4. 2 goes into 2 once. 2 goes into 4 2 times. And now I'm going to go ahead and I'm going to get my answer. My answer is going to be 3 times 2, which is going to give me a 6. Okay, so that is how you're using combination. All right, looking at my formula for combination again, we kind of went over this already. The only difference is what's right here. That times r. That's the only difference between my combination and permutation. So please make sure you know that it has that times r in your denominator when you're solving it and writing it out. Again, you have to write this out. I need to see the work. Yes, you can do it on your calculator, but I need to see it written out, please. Looking at example number 6, it says you order a sandwich at a restaurant. You can choose 3 side dishes from the list of 8. How many combinations of side dishes are possible? So again, it specifically says combinations. So I'm going to go ahead and solve using my combination. How many total do I have? That's going to be my n, which is 8. How many can I select? They told me 3, so I'm using combination again. So looking at this, I'm going to have 8C3. Solving this, I'm going to have 8 factorial over 8 minus 3 factorial times 3 factorial. Solving it, I'm going to have 8 factorial over 5 factorial times 3 factorial. So looking at this, I'm going to have 8, 7, 6, 5. Pay attention on why I'm stopping at 5, because if I have 5 for the next one, which is right here, everything after that is going to cancel out. However, I still have the 3 to account for, so I'm going to write 3 times 2 times 1. Okay, that is not canceling out. I'm not simplifying that yet. Now looking at it, I can simplify. What can I simplify here? What's 3 times 2? 6. So 3 times 2 is going to give me 6. So then I'm going to go ahead and cross out my 6 here because that's just going to give me 1 and 1. So now all my denominators are 1. What do I have left over? I have 8 times 7 left over, which is going to give me my total of 56. So how many combinations of side dishes are there? 56 combinations using 3 of my side dishes from the list of 8. This one specifically tells you, again, it's a combination. Okay, so order does not matter for this one. Looking at example number 7, it says a yearbook editor has selected 14 photos, including one of you and of your friend. You use to use in a collage for the yearbook. The photos are placed at random. There is room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the 2 placed at the top of the page? Keep in mind, this is not giving me a specific place. What do I mean by that? It's not telling me, was I chosen first, was my friend chosen second? It's not being specific. It's just saying, okay, 2 photos were placed at the top. What is the probability of my teacher selecting me and my friend? Again, a couple things it didn't say. It didn't say, was my friend chosen first? It didn't say my friend was chosen second. It's just 2. Whether I was chosen first or my friend, it doesn't matter. Order does not matter. So if the teacher is selecting 2, only 2, what is the probability of those 2 being my friend and myself out of the total 14? So this is a combination question. Using combination, I'm going to do the same thing as I did before. What is the probability? Let's see, okay, how many combinations can there be in total? So I'm going to have my total number, which is 14. N equals 14. R is going to equal 2. Solving it again using combination, I'm going to have 14C2, which is the same thing as saying 14 factorial over 14 minus 2 factorial times 2 factorial. So solving this one, I'm going to have 14 factorial over 12 factorial times 2 factorial. Writing it out, I'm going to have 14 times 13 times 12 factorial. I'm going to stop there because everything after this 12 is going to be canceled. And do not forget, you have to take into consideration that 2. Can I simplify anything here? Yes, I can. I can simplify my 14. 2 goes into 14 7 times. All I have is 7 times 13 left over, and that's going to give me 91. So my total outcomes for this question is 91. And what's the probability of her selecting me and my friend? How many can she select? Only 2. Remember, order doesn't matter. So if she's only selecting 2 and I want me and my friend to be selected, there's only one possibility of the teacher selecting me and my friend. There's only one, because it's only the 2 of us and she's only selecting 2. So there's only one possibility of her selecting us. Example number 8 says, your teacher randomly chooses 2 out of 18 students to give an impromptu debate on freedom of the press in high school newspaper. What is the possibility that your teacher chooses you and your best friend? Again, very similar question. It's not saying me first, my friend second. It's not giving me a specific order. It's just saying me and my friend. What are the likelihoods of her choosing us? Again, she's only choosing 2 people, and I want it to be me and my friend. So same thing as we did before. I'm going to go ahead and look at it. I have the total number of students that she has, which is going to be 18. How many is she choosing? 2. So I need to find my total outcomes. How many are there? How many possibilities are there? So I have 18C2, which is going to be 18 factorial over 18 minus 2 factorial times 2 factorial. Solving this one, I'm going to get 18 factorial over 16 factorial times 2 factorial, and writing it out again. 18 times 17 times 16 factorial. I'm going to stop there because everything after my 16. These are going to cancel out. Don't forget, I still have that 2 right here. And I can simplify. I'm going to go ahead and simplify. 2 goes into 18 9 times. And then just 9 times 17. You can do that on your calculators. 153. So out of the 153 choices, what's the probability of her selecting me and my friend? Only 1. 1 out of the 153. Go ahead and try these examples on your own. Please make sure you're writing the work out. But yes, you can check yourself using your calculator. I'm going to give you guys a few minutes. All right, let's go ahead and check the first one. So looking at my first one, I'm going to have 10C8. It's going to be smaller. I know the 10 and the 8 is pretty big, but it's going to be a little smaller. I have 10 factorial over 10 minus 8 factorial times 8 factorial equals 10 factorial over subtracting. I'm going to get 2 factorial times 8 factorial. Writing it out, I'm going to get 10 times 9 times 8. I'm going to stop there because everything after this 8 will be canceled out. Don't forget you still have that 2 times 1. Simplifying, 2 is going to go into 10 5 times. And what do I have left? 45. That one should have been pretty quick. You didn't necessarily need your calculator if you got up to this point. Looking at the next one, it's going to be a little longer, but it's pretty fun. Yeah, it's fun. I'm going to have 24C10, which is the same thing as writing 24 factorial over 24 minus 10 factorial times 10 factorial. Simplifying it, solving what's in parentheses, I'm going to have 24 factorial over 14 factorial times 10 factorial. So this one's going to be a little longer to write out because I'm going to go all the way down to 14, 24, 23, 22, 21, 20, 19, 18, 17, 16, 15 times 14 factorial. I'm going to stop there because I also have a 14 here. We know those are going to cancel out. Now I'm going to go ahead and do my 10s. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right, please pay attention to how I'm solving this. Let's say you just didn't have a calculator, you couldn't do it. This is pretty easy. You can multiply to cancel out, to simplify them. So looking here, this is what I said was fun. You just got to know your times tables. So looking at it, I'm going to go ahead and simplify 10 times 2. What's 10 times 2? 20, so I can go ahead and simplify that and cross it out. What's the next one? What else do I have? All right, 9, good. 9 times 3 is what? Oh, we can't use that one. 9 could go into 18. How many times? 2 times. What else? Well, 6 times 3 is what? I can't use 6 and 3 because I already canceled out my 18. What else can I do? 8 times 3 is what? So cancel out. Okay, what else? 7 could go into 21 how many times? Okay, so I could go ahead and simplify that one. 7 goes into 21 3 times. What's 3 times 2? So I could cancel out my 6 and my 3 and my 2. What about 5? 5 and 15? 5 and 15 is what? 3. What about 4? Okay, good. 4 and 16. 4 goes into 16 how many times? 4 times. So now if you're looking at it, everything on your denominator right here is just 1. So all I really now need to do is multiply what's left over. So you could plug this into your calculator. 23 times 22 times 19 times 17 times 4 times 3. If you plugged it in correctly and you solved it correctly, your answer would be 1,961,256 if you did it correctly. Okay, questions on this one? Okay. All right, do we have any questions on this? Yes, question. The last question. What about the last question? You don't know that. Maybe. But you have your calculator. You could plug it in. It's pretty easy. You will just have to multiply if you don't know how to use the NCR button. That's it.